Okay, now let's look at the problem number 15. Projectile is fired in such a way that its horizontal range is equal to the 3 times its maximum height. What is the angle of projection? Okay, let's look at how we can solve this problem. Okay, so let's draw it. So we know that projectile is fired with initial velocity at a certain angle. Okay, we also know that when projectile is launched, we know that it has a maximum height. So let's call it h max, and we have a range which is delta x. Okay, the condition here says that delta x is 3 times of h max. Okay, if it's a condition, then we have to find what is the angle theta. Now, I don't want to derive all this formula. I want to show you the ready one, which means if you want to find delta x is equal v initial squared multiplied to the sine 2 theta divided by g, and for the h max we have a formula which is v initial squared sine squared theta divided by 2g. Right now, let's plug delta x and h max to the h max. So that means if the condition was that delta x is equal 3 times of h max, then we can say that v initial squared sine 2 theta divided by g, right, then is equal to 3 times v initial squared sine squared theta divided by 2g. So obviously we can just cancel this v initials, we can cancel the g. Then at the end we are going to end up with okay, so if it goes there, so let's make a cross multiplication. So 2 over 3 is equal sine squared theta divided by sine 2 theta. Now we know that sine 2 theta is equal to 2 sine theta cos theta. So that means this one will cancel with that one. Then we will end up here tangent theta over 2. Now again, let's do a cross multiplication. So we'll end up with 4 over 3, which is equal to tangent theta. Now from here, let's find our theta. Theta is equal inverse tangent 4 over 3. Now if you do calculation, inverse tangent 4 over 3 should give you 53 degrees. So as you can see here, our theta was equal to 53 degrees. This is how you solve this problem.